Hello there. In this tutorial, I will cover the basic logic of a 2D platformer in Python with Pygame. So we will have a level. Inside of that level, we have a player. The player can move around and jump. Then we have a camera following the player, and we have all the collisions to make the game work. That's basically it, and that's all you really need for this sort of game. Now, obviously, it doesn't look terribly good right now, but if you added graphics and a bit more effects, it can look really good. I have actually made a whole tutorial on this kind of game. Now, unfortunately, this tutorial had one major flaw, that the player camera wasn't exactly working perfectly. So we had a couple of bugs once in a while. And this is what this tutorial is fixing. So we are essentially going to create a much better player camera. And I guess really quick before I jump into the project, we are only going to have one folder, and that one is going to contain all of our files. And we only have Python files in there and nothing else. And well, with that, let's start with part number one, the project setup. So I already have a couple of things in the code that I would like to go over before we actually jump into the project. Here we are in the project. If I run this code, we can see a window that has a dark bluish background. We right now have two files. We have main.py and we have settings.py. And main.py is the main file we are going to work on. And in here, really not much is happening. All the way at the top, we are importing the things we need for Pygame. So Pygame and sys, and then below that, we are importing settings. So this file here. Then below that, we are initiating Pygame. So we call the init method, then we are creating a screen and a clock. All the basic stuff you need. Then we have our game loop, and in there we have our event loop, we are filling the display surface, and then we are updating and calling the clock. And all of this should be really simple if you understand basic Pygame. If you have no idea what I just talked about, check out my introduction to Pygame. This one is going to explain all of this in quite some detail. But alright, the other file we have is settings. So let's have a look at that. First of all, we have our level map, and this one is a list with a couple of strings. And this is going to be our level layout. I will go over this later on. Besides that, we have a couple of basic attributes of our game. So the tile size, the width, and the height of our window. I guess all of those are kind of straightforward. Then below that, we have a couple of colors. And well, it's just a couple of color arguments, nothing fancy here. And finally, we have what is called camera borders. And essentially what this one is doing, let me draw this actually. So if this is our entire game window, so this one would be 1280 pixels wide and 720 pixels high. This is the stuff we defined here. Inside of this, I want to have a camera that is right now 100 pixels from the left. That's this number here. Then also 100 pixels from the top. That's the top part here. Then from the bottom, we have 150. And from the right, we have 200. So essentially these camera borders are, well, the borders of our camera once the camera starts moving. So this area here, and essentially if the player goes further to the right than this, then we are moving the rectangle in the same direction, and this is going to show a different part of the game. It's, well, a camera. I hope that makes sense. We'll go over this in quite some detail later on, but for now, don't worry about it, I suppose. Now, there's one more thing I would like to do, and that's going to be a challenge for you. That right now, if I run the game, in the top left, it says Pygame window, but I would like to rename this to something more appropriate. Let's say in my case, platformer. And this could be a challenge for you. So try to change the title of our window yourself. All we need when we are initiating a game, we have to call pygame.display and then set_caption. And then here we have to pass in a string of what our title is supposed to be. In my case, platformer. And now if I run this, we have platformer. That does feel better. Now with that, we have the basic setup. So next up, we can talk about the level setup. And in here, we have to consider a couple of things. Let me talk through them. Number one is we have to create a level class, and this one is going to contain the game. Most importantly in here, it is going to contain all of the sprite groups. And we are going to have a couple of different ones. I'll go over them in just a bit. But this is essentially the most important thing the level class has to do, because these sprite groups will be responsible for updating and drawing all of the game's assets. So this one is going to be really important. Now, besides that, we have to create a class for the player and for the level tiles. And both of those are going to be sprites. And for now, we will keep the player a bit more simple. We're going to add proper controls later on. And finally, we have to convert the layout to an actual level that you can see on the screen. Right now, our level is just a list with a couple of strings, not particularly helpful. So we have to turn this information into actual positions on the screen. That's going to be a bit of a larger section, but this is all we need for now. And let's start with the first one, that I want to create a level. And this I want to create in a new Python file. And let me save this one as level.py. And in here, first of all, we have to import Pygame as always. And besides that, I also want to have my settings. So from settings, import all of it. Now, what I want to do is I want to create a class called level. And there's no need for inheritance. And the basic idea is now going to be that this level is going to have a method that I called run. And this run method is going to run the entire game, or more specifically, the level. And then this run method, I want to call for my main file. So in my main.py, I want to, from level, import level. Then I want to create an instance of this class. Let's just call it level. It's going to be level. We have no arguments. And then in my game loop, I want to call level.run. And this way, our entire game logic is going to be contained inside of this level class, which is quite a nice way of organizing the game. So now all we have to do is figure out the entire rest of the game. And let me just add a pass in here so we don't get an error. The first thing I want to do is to create a dunder init method to set up this class. And for now, I just want to have one basic thing, and let's call it level setup. And the thing I want to get is self.display_surface. Since I want to run my entire game inside of run, I need to get my screen so that I can display something to the player. And this we can get in a couple of different ways. We could, for example, create a parameter and pass in the screen in there as an argument. Would be perfectly fine, but another way that I prefer is just to call pygame.display.get_surface, and this one gets you the same thing. So now we have the surface we want to draw on, but the other thing we need is our sprite group. Let's call it setup. So in my case, I want to create 3 different sprite groups, and let me name them. So self.visible, sprites, and this is going to be pygame.sprite.group. And then I want to have 2 more groups. The first one I called active sprites, and the other is going to be the collision sprites. So now our game has 3 different sprite groups, and let me explain what they are supposed to do. They are not actually that difficult. First of all, we have our visible sprites, and this one is going to be the only group that draws anything. So if a sprite is not inside of this group, it is not going to be drawn. Next up, we have our active sprites. And this is going to be the only group that updates any sprite. So if a sprite isn't inside of here, it's not going to be updated. So for example, our player is going to be in here, but our sprites for the level are not going to be in here because those are going to be static. And finally, number 3, we have our collision sprites. And these are going to be all of the sprites that can collide with the player, or well, that the player can collide with. Now, you might be wondering why this kind of excessive setup. For example, why couldn't we combine the visible sprites with the active sprites? And you actually could. In our example, it wouldn't make that much of a difference. But I want to have this project scalable for a larger game. For example, in the Zelda game I made, you have quite a few tiles that are not visible, but that do influence the player. And this was done with different kind of sprite groups, so this can be very powerful. And this system is actually also a bit more efficient, because you only want to update the sprites that need updating. So if you don't need any updating, you don't want to call this method on them. And if we put all the visible sprites and all the active sprites in the same group, you might be updating some sprites that don't need updating, which would be a small waste, but a waste nonetheless. If you ever make a larger game in Pygame, you are really going to appreciate this kind of system. But alright, that was a lot of talking. But now we have our basic setup for the level. We have now finished the first part. And let's start on number 2. That we are creating a class for the player and for the level tiles. And let's do this straight in the project. It's not that difficult. Now, the first thing I want to do is to create 2 more files. The first one I have called tile.py, and the second one is going to be player.py. And let's start with the tile, that's the easier one. In here, we again want to import Pygame. And besides that, from settings, import all of it. Now, next up, I want to create a class tile. And this one has to inherit from pygame.sprite.sprite because it is going to be a sprite. So what we are going to need now is an init method that needs self. And I want to have 2 more parameters. The first one is the position, and the second one is the groups it's supposed to be in. And now inside of this init method, I want to first of all call this super and then the dunder init method on this one. And in here, we have to pass in our groups. So essentially, when you add in the groups inside of this class, when you set it up, this sprite is automatically going to be assigned to these groups. Makes the setup quite clean. Now, besides that, we have to create a self.image and a self.rect. And for the image, I want pygame.surface. And then here, we have to add a tuple with the width and the height of what we want. In my case, let me open up the settings. We have a tile size, and that is 64 right now. So each tile should be 64 by 64 pixels. Essentially, all I have to do is pass in the tile size in here, then copy it for the height as well, and we are good to go. Now, for the rect, we want to do self.image.get_rect, and in here we have to specify the position. In my case, I want to place the top left where the position is. So the position we created up here, and we just pass it in here. And there's only one more thing that we need. That right now, this image is going to be black, which is not the ideal color. So I want to fill it with a color. And this happens with self.image.fill. And in here, the color I already have is the tile color. So I want to pass this in here. And now we are good to go. We can't see anything yet, but that's going to come very soon. So next up, we can work on the player. And for now, this one is going to be very simple. All I really want to do for now is that we have something for the player to show where the player is. So it's going to be very similar compared to the tile, with the only exception that the player is half as wide as a regular tile. And this, I think, could be a really good exercise for you. Create a player class that is basically like a tile except half as wide. Now, to save me some writing, I am just going to copy all of this and paste it inside of my player. Then I want to rename the tile to player. And there are actually two differences. I forgot to mention one. Now, the first one is in this line that right now we have a width and a height of 64 and 64. But I want the player to only be 32 pixels wide. And the way to do that is we can just divide the width by 2. And that's literally all we needed. And the one thing I forgot to mention is that I want to have a different color for the player. So I don't want the tile color. Instead, I want the player color. And well, with that, we have a tile and a player. Now the player for now is very simple, but in the next section, we are going to make this significantly more complex. But before we can get to that, we have just finished the second part of what we have to cover. So now we have a class for the player and for the level tiles. So finally, we just have to convert our layout to an actual level and then place all of our classes in such a position to actually have a level. And this is the part that is going to need a bit of explaining. And let me do this straight in the code. That should make the most sense. In my settings right now, I have this level map. And this level map is literally just a list that starts here and ends here. And inside of this list, we have a couple of strings. The first few are completely empty. So in all of this, there's absolutely nothing. However, a bit further down, we have a couple of X's and we have a P. The P stands for the player or the starting position of the player, and the X stands for each of the tiles. And essentially what I am going to do is I'm going to use the position of each of these characters inside of this list to get a position for each of them. And let me explain how that's going to work. For each of our tiles, we are going to need an X and a Y position. And let's start with the Y one. You're going to see in a second why. The easiest way to think about this is to think of this list as some kind of table, where each of the strings is one row. So this would be row 0, this would be row 1, row 2, row 3, row 4, and so on. So for example, I know that all of these X's here are in the third row. And I also know that the height and the width of each of my tiles is 64. That is the information I get from down here. So really, all I have to figure out is this distance here. And this distance is going to be the row, so in this case it's going to be 3, multiplied with the height of each row. And that's going to be 64. So for this entire row, we know the starting position for Y is going to be 192. And that is all we need here. So what I basically want is the row index multiplied with, let's call it the height. Next up, we have to think about X. And X is going to work slightly differently. We have to go through each individual string inside of this list. Let's go with the one at the bottom here. And the system is going to work kind of similar compared to the Y position. Each of these X's has an index. So we start with 0 again, we have 1, 2, 3, and so on. And we know that each of these X is supposed to be 64 pixels wide. So let's say to get to the block with the index number 2, what we essentially need is the number of the index. So this is going to be number 2, and then multiplied with the size of the block, which is going to be 64. So we know that this position here, the left side of this X, is going to be 128. Or in more general terms, all we really need is the column index multiplied by the width. Once we have this information, we can just write a for loop and go through all of this. So let's actually do that. And all of this I want to do inside of my level. Now, before we can actually use any of this, we have to import the tile and the player. From tile import tile, and from player import player. And now I want to create a new method. Let's call it setup level. We don't need any arguments. And in here, I first of all want to go for row in, and this is going to be in this level map. So in level map. And let me just print what we get. So I want to print a row, and don't forget to actually call self.setupLevel. Also, it's kind of important that this level setup comes after all of the other setup. Because in a bit, we are going to place sprites inside of these groups here. So they have to exist before we set up the level. But now, this should actually be working. Let's actually try what's happened. So we still get a window, but that's not what I care about right now. What I care more is what's happening down here. This is what we have just printed out. It's basically line by line what we have in my settings here. This level map. Which is a pretty good start. But this actually isn't the information we really care about. Because what I want to know right now is what the index of this row here is, for example. And right now I only have the content. I don't know what the index of this is. So we have to get that. And this is what you get with the enumerate method. And basically what this one does is it returns an index of where you are in the for loop and then the actual information. So what we can do now, for example, let's put all of this inside of a f string where we have, let's call it the index and then the row. And now let's run this again. There we go. With the enumerate method, I know that this is row number 0, number 1, number 2, number 3, and so on. And this is then what I can use to calculate the Y position, which is actually quite simple. Let me actually put it here in the F string for now, just to illustrate what's happening. So let me add an arrow, and all I really have to do is multiply my index with my tile underscore size. So now if I run this again, we get the window again that I still don't care about. But now we can see our Y position is going to be 0, 64, 128, 192, and so on. And this is the actual position on the map that I care about. So this is working quite nice. But now I also need the X position. And this is going to be another for loop inside of this for loop. So let me illustrate what's happening. That right now, inside of this level map, we basically went this way and we looped over every single string. What we now have to do is to go this way, where we are going to loop over every single item inside of each of the strings. And this is going to look fairly similar. So what I want to do for now, let's call it for column in my row. And this is going to return each individual string. But just like we have done here, I don't, at least for now, really care about the string. I care about the index of that string. So I want to put this thing inside of the enumerate method as well. So we're going to get an index and a column. And we have to be a bit better with the naming. We can't have index twice in here. That's going to be confusing. So let's call the first one the row index and the second one the column index. And now inside of this for loop, I can get the X and the Y position. And Y we already have. It's basically the thing we have created here. So let me just cut it out, paste it here, and let's get rid of this entire thing. We don't need it anymore. with the one difference that we call this row index instead of just index. And for the x, all we really need is the column index multiplied by the tile size. So with that, we have our x and our y position. So now what we can do, in our tiles, we have a position and our player also has a position. And I also know where there's supposed to be a tile, wherever we have an x, and the player is supposed to be where we have a p. So in this for loop, all I have to check is if the column, so the actual string, is equal to an x, then I want to create a tile. And if the column is equal to a p, then I want to create a player. And let me copy the parameters. They both have the same ones. So we need a position and a group. Now the position is fairly simple. For both of them, it's going to be x and y. So let me here really quick. That looks good. Now for the groups, they are also going to be identical for now. And they need to be in a list. So in here, I want to have a list with my self.visible sprites. And this is going to be the same for both the player and for the tiles. Oh, and this tile should just be tile. And all right, so with that, we have our level set up. So if I run this, we can't see anything, but we don't get an error. That's usually a good sign. Now, the reason why we couldn't see anything is because we are not drawing any of these classes. But this we can change quite easily. All I have to do is get my self.visible sprites and draw them. And I want to draw them on the self.display surface. So now, there we go. We have our level set up. This is looking really nice. So with that part covered, we can come to the next major section. And that is going to be the player movement. And the player movement isn't all that difficult. Essentially, here's what we have to do. We are starting with our player rectangle. That one is what actually moves the entire sprite. And on top of that, we are going to give it a direction. And this direction is going to be a vector 2. And all that really means is that we have an x and a y part to this, with x being left and right and y being up and down. And then this direction we are going to multiply with a player speed. So for example, if our player speed is, let's say 5, and for some specific numbers for our vector, let's say x is going to be, let me put it here. So if our vector has a direction of 1 and 0, if we multiply this vector with 5, this would give us a new vector of 5 and 0. And this would effectively mean that we want to move this player rectangle 5 pixels to the right. So for example, if the y part wasn't 0, it would be something like 10. Then I want to move this player rectangle down by 10 pixels. And you could basically add any kind of number in here. They would all move the rectangle in a certain position. Now for all of this, the really important part is that our direction is going to be influenced by the input. And this one will determine left, right, and jump. And on top of that, we also need the gravity. And to make all of this work, we have to address a couple of things. First of all, we have to give our player direction and to make it accept input. Then we have to use the direction to move the player on every frame. And finally, we also have to implement the gravity. And that is all we need. Let's have a look at all of this. Here we are back in the code, and I, for now, want to work inside of the player. We already have a couple of things, and there's one more part I want to add. And let's add a whole section, let's call it player movement. And first of all, we need a self.direction. And this one is going to be pygame.math.vector2. And this line basically creates a vector with x and y that both by default are 0 and 0. So if we added this vector to the player, it wouldn't move the player at all. Or well, it would move the player, but by 0 and 0. So it would move it in the same place. The other attribute I want to give my player is self.speed. And in my case, I went with 8. But in here, you can basically go with whatever looks good. And now that we have that, we can start working on the input. We need self and nothing else. And for the input, first of all, we have to get all the possible keys. This happens with pygame.key.get_pressed. And these are all the keys that could potentially be pressed. So what we can do with that, we can check if inside of the key we currently have pygame.kwrite. This basically checks if the player is pressing the right key on the keyboard. And if that is the case, I want to check self.direction, get the x part of the vector, and set this one to 1. And now I can copy all of this and change the right to left and change the if to an elif. And then x shouldn't be 1, it should be -1, meaning that we are now moving to the left. But now we have to add one more thing. Let me explain why. This here right now is our player. And let's say the player has moved to the right. So we are moving in this direction, meaning that in our vector, we have a vector of 1 and 0. The problem we have now is if the player stops pressing to the right, then our vector doesn't update. So even though the player doesn't press right anymore, the vector still points to the right. So this one here needs to return to a 0 once we stop pressing the right button. And that we can implement fairly easily. All we need is an else statement and set self.direction back to 0. And with that, we have the left and the right movement. Now, the other thing we need is the jump mechanic. And this we can basically check with if keys, and if they are pygame and k_space, then we want, for now, let's say we want to print jump. I'm going to implement the jump mechanic probably later on. For now, don't worry about it. But okay, with that, we have our input and we have the player vector and the player speed. Which means that we already covered the first part in what we have to do. So next up, we have to use that direction and actually move the player on every frame. And that is going to happen in the update method of the player. And for now, all I really want to do in here is get myself.rect, and then we need one of the points of the rectangle. It doesn't really matter which one. So in my case, I'm just going to go with top left. And we want to add self.direction and multiply this with self.speed. Although there's one thing I forgot, that right now we are not calling this input method. And let's do that at the top of our update method. So self.input. But now we have another problem. We are not actually calling this update method. And this we have to solve in our level. Because in here, we have our active sprites. So basically what I want to do, before we are drawing all of our sprites, I want to get myself.activeSprites and update them. But right now, the active sprites are empty, so our player isn't inside of them. And to fix that, we have to place this self-active sprites inside of the list for our player groups. And now we should be good to go. Let's try this. So if I run the main file, we are getting an error that self.rect.top left has a problem that we can only concatenate a tuple, not an int, to a tuple. So let's have a look at our player. And right now, the direction is the problem. And I see where I went wrong. In this line here, if the player isn't pressing right or left, then we are running this. And we are setting self.direction to 0. So the entire vector becomes the integer of 0. But we only want to set the x part of this vector to 0. So this should fix it. And there we go. And now, if I press right, we move to the right. If I press left, we move to the left. This is looking pretty nice. Cool. So with that, we already have left and right movement. And that means that we basically covered the second part. So all we have left is to implement the gravity and the jumping mechanic. And that's going to work in a somewhat similar way, except now we are not using the input. Instead, we use gravity or jump mechanic, which I guess is input, but you get the idea. Now, back in the player, I want to add a few more things. First of all, our player needs some kind of gravity. And in my case, I've set this to 0.8. But for this one, basically choose a number you think looks good. What is physically accurate really doesn't matter. And then besides that, I want to have self.jump_speed, which I have set to 16. And this is essentially how high our player can jump. And with those two covered, we just have to figure out how to implement them. And let's start with the jumping by itself. Essentially, when the player presses jump, then I want to set self.direction.y is equal to self.jumpSpeed. Although, be aware here, right now our jump speed is positive. So this 16 greater than 0, meaning that this would move us downwards in the game. Which isn't exactly how jumping works. So what I want to do instead is to set a negative here. And now what that is going to do, if we actually run the game, I press space, our player moves up so fast that, well, you can't really see it anymore. And the problem here is that once we set direction to 16, we have no way to counteract this number. So it keeps on 16 and our player keeps on moving upwards really fast. And to fix that, we need gravity. And let me put this in a separate method, and let's call it apply gravity. We don't need any parameters, and all I really want to do in here is I want to get my self.direction.y and plus equals self.gravity. But now we kind of have a problem, because when we implement the actual movement, this line down here, we are multiplying our direction with the speed. And this right now would also include the gravity. So our gravity would be multiplied by 8, which would make it way too high, which is pretty bad. So essentially what I want to do is I want to split this line here into two parts. So let me duplicate this line. And I first want to get the x and then the y. And then I want to get my direction.x and direction.y. And those two lines are going to do the exact same thing. We have now just split one line into two, which isn't particularly helpful, but now we can use this to move the y part inside of our apply gravity and get rid of multiplying it with self.speed. And that way, we don't multiply the gravity with the speed. And all that's left to do is to actually call it. So self.apply gravity. And now let's run this. And there we go. We have a player that is capable of moving around. That's looking pretty good. We don't have any collisions yet, so it's not particularly realistic, but at the very least, it is working. And with that, we have covered the third part to give our player gravity and the jumping mechanic. And the next part is going to be collisions. And let's go over the basic idea of collisions. essentially what I want to do. This white rectangle right now is my player, and I want to move my player to the right. So we just keep on going to the right, no collisions yet. But now we do have a collision that might look like this. So our player is overlapping with an obstacle. What I essentially now want to do is to move the right side of my player to the left side of the obstacle. And the same logic would apply in all 4 directions. So for example, if my player was to go down, let's say in this direction, and now we have an obstacle, then I would want my player to be exactly on the top of the obstacle. So this line here. And that way our player cannot go over any kind of obstacle, which is a pretty good start. But there is a problem. And let me illustrate this. The question essentially is, if we have a scenario like this, which side actually collided? Is it the left side or the top side? The answer is we don't really know. There's quite some ambiguity here, which obviously is really bad. And in the game, this might end up looking very glitchy. For example, if our player was moving to the right, we would want to move the player to this line here. But if our collision messes up, we might end up putting the player on this line here. So we essentially teleport the player around because we don't know where to put the player. And the solution to all of this is that we are first going to check the horizontal collisions and then the vertical collisions. And that way there's no ambiguity in terms of where we collided. And in terms of what we actually are going to do in our code. Our player needs to know where the obstacles actually are. That's really important to make all of this work. Then next up, we have to implement the collision mechanics. And finally, we have to combine the move and the collision methods, because those two are very closely linked. And let's start with number 1, that the player needs to know where the obstacles are. And this is going to happen inside of my player. Right now, I only have all of my tiles inside of my visible tiles. But now I also want to add them to my self.collision sprites. And that way I already have all of my tiles inside of one list. And this list I want to pass into my player. Now it's really important that this is going to be a new parameter. It is not part of the groups for the player. So these are the groups the player is part of. And self.collision sprites is not inside of that. It's a whole new argument. This distinction is really important. And what I really want to do is in my player, after groups, we have, let's call it the collision sprites. And let's put this at the end of our player movement. So in here, self.collision sprites is equal to collision sprites. And this way, our player is going to know where the tiles are going to be, which is already the first part we have to cover. So next up, we can work on the collision mechanic. And that is going to be its whole separate method. And to really emphasize that we have a vertical and a horizontal collision mechanic, I am going to create 2 methods. The first one is going to be the horizontal collisions. We need self and nothing else. And now I want to copy this, and this one is going to be the vertical collisions. And for now, let me add a pass in here. And let's work on the horizontal collisions by themselves. Although in an actual project, you could combine these 2 methods. It's not strictly necessary to separate them. And in here, I want to check for sprite in self.collision sprites.sprites. And this is going to cycle through all of the sprites. And in here, I want to check if my sprite.rect.collide rect with my self.rectangle. This line basically checks if our sprite, so this one here, is colliding with the rectangle of the player. Self.rect is the rectangle of the player. And if that is the case, I want to figure out if I want to place my player to the left or to the right of this obstacle. So I have to figure out if my player is coming from the left or from the right. And for that, I can use the direction. So if self.direction.x is, let's say, smaller than 0. If that is the case, I know my player is moving to the left. So if we now have any kind of collision, let's say here, I can be pretty certain that this is going to be on the left side of the player and on the right side of the obstacle. So what I can do is self.rect.left is going to be sprite.rect.right. And then I can copy all of this and check if my x is greater than 0. And if that is the case, the right of my player should be on the left of the obstacle. And that is literally all we needed for the horizontal collisions. What I can do now in my update method, after I do the horizontal movement, I want to call self.horizontal collisions. So if I now run the game, I can still, this is going to be kind of hard to see, but let's say there you can kind of see that we are definitely being moved to the left or to the right of some obstacles. Right now, it's kind of difficult to tell because we have no vertical collisions. But I guess you can kind of see it's somewhat working. But let's implement the vertical collisions and make all of this work. And I think this could be a good exercise for you. So try to copy the horizontal collisions or the vertical collisions and make this work. First of all, I want to check again for sprite in self.collisionSprites.sprites. And inside of that, if sprite.rect.collide rect with self.rect, then we want to do something again. And in here, I now want to check if my direction.y, let's start with, is greater than 0, meaning our player is going down. And if that is the case, self.rect.bottom should be in the same position as sprite.rect.top. And if my direction.y is smaller than 0, then I know my player is going up. So self.rect.top should be sprite.rect.bottom. And now all I have to do is to call self.vertical collisions after we have applied the gravity. That is kind of important, so make sure to have the order here right. And now let's try this, although there is going to be a problem. And, well, we do have an error actually. Name.direction is not defined. Let's have a look inside of my player. This should be self.direction and self.direction everywhere. Now let's try this again. There we go. Now our player is having pretty good collisions, but you can see there our player disappeared. And, well, why did that happen? Let's say this here is our player. And our player right now stands on top of a tile. And we have no movement at all right now. However, even if the player doesn't move at all, we still have gravity. So what happens early on is that the player moves down a tiny bit. But since we have a collision here, this movement is being counteracted and our player is put here. The problem we have right now is that we keep on increasing our gravity. So this one here keeps on becoming larger and larger, which effectively means that this arrow becomes larger and larger on every single frame of the game. Now, up to a certain point, this is being counteracted by our collision mechanic that always puts the player on top of this line. ignore this bit here. I bet it wrong. So all of these arrows put the player on top of this tile. However, at some point, this arrow is greater than the height of this tile. And at that point, the player isn't here anymore, the player is here. We essentially jumped over the entire tile. And after that, the player just keeps on falling and we can't see it anymore. And as a consequence, we have to figure out that if the player is on the ground, we don't want to apply gravity anymore. And that's kind of easy actually. And essentially all we have to do in the vertical collisions, if we are in this point here. So if you want to place the bottom of the rectangle on top of the sprite, I also want to set self.direction.y to 0. And well, now let's try this again. And now, even if I wait, the player does not fall through any of the other tiles. But here we can see another problem, that if the player hits the ceiling, we kind of hover around, which looks a bit strange. And the issue for that is, so here again, we have our player, and this time we want to go up. But we cannot go up any further because there's a ceiling. But the problem is that this arrow is still quite substantial and much larger than the gravity. So once we hit the top here, it takes gravity, let's say half a second, to be greater than this arrow. And during this time, the player just hovers on the ceiling, which looks kind of strange. But this we can also fix fairly easily. All we have to do, if the player is hitting a ceiling, we can set self.direction.y also to 0. And now, if I hit a ceiling, we don't get the hover effect anymore. So this is looking pretty good. Although now we do have another problem, that the player can keep on jumping forever, which is, well, not ideal, although it's kind of fun to do. So we have to limit the player's jump to only be able to jump if we are on the floor. And for that, I am going to create another attribute that I called self.onFloor. And this one by default is going to be false, although it doesn't really matter what you put in here by default. And now I only want to allow the player to jump if we are pressing space and if self.onFloor is true. And right now it's not, so our player is not able to jump. But we are still able to fall just fine. Which means that we just have to figure out when to set self.onFloor back to true. And this is going to happen in our vertical collisions. So let me minimize the other methods. It's getting a bit crowded. Basically, if our player is hitting the floor, so on this line here, then I want to set self.onFloor to true. And we can actually try this. So now I'm on the floor and, well, it kind of worked, although we can still double jump. And, well, let me explain what happened. Our player is this again, and we are standing on the floor, which means that this on floor is being triggered. And if we now jump, our player is in the air. The problem is we are never switching off this self.floor after the player has jumped. So we need to find a way that once the player is in the air, self.floor goes back to false. And you might be tempted to put this in self.input, that if the player is jumping, we want to set self.floor to false. But that wouldn't exactly work, because another way to leave the floor is if we had a cliff here and the player is jumping down there. We also want to account for that. So we essentially want to check if the player has a negative y or a positive y, and then we are not on the floor anymore. And that we can also put in the vertical collisions. Basically, what I want to do in here is if self.onFloor is true, and then I also want to check if self.direction.y is different from 0. So if we ever go up or down. And if either of these is true, then self.onFloor should be false. And the basic idea here is that if our player is on a floor, if that is the case and the player manages to either go up or down, we can pretty reasonably assume that the player has left the floor. And let's try this. So now I cannot jump more than once. This is pretty good. And if I fall down a cliff, I also cannot jump again, even though we have left the floor. So this seems pretty good. And this is working really well. Now the final problem is that we can just jump outside of the level and you can't see the player anymore, which is going to be the next section. But first I got a bit ahead of myself and we covered the collision mechanics and we also combined them with the movement. So we did all of this in one go. And with that covered, for the final bit, we have our player camera. And for this, I do have to cover a tiny bit of theory. And the fundamental idea that you have to understand is this, that when we draw anything in Pygame, we basically get a rectangle and we put a surface inside of that rectangle. So those two have the same position. And that works pretty well for most circumstances, but a camera basically uses that system and plays with it, in the sense that we don't necessarily have to put the surface where the rectangle is. And what that means in practice is this. Let's say we still have our rectangle, but now we are using a vector offset to draw the surface somewhere else on the screen. And this is then basically going to be the camera, that this offset moves surfaces either left or right or up or down or wherever you need them to be. And if that vector offset then comes from the player, we have a camera that focuses on the player. And that's really the basic idea here. We essentially give all of our vectors an offset so that we are drawing all of the surfaces somewhere else on the screen. So there's going to be a disconnect between where stuff is in the level, as in where the rectangles are, and where we are drawing our surfaces. But once you are understanding that principle, a player camera actually isn't all that difficult. Now, in terms of code, what this means is that we have to create a custom draw method, and in our case, this is going to be the visible sprites group. So we are going to overwrite that. And let's approach this in the code. I think that's going to make the most sense. Here I'm back in my main.py file, and inside of my level, we have our visible sprites. So this sprite group contains all of our elements. And right now, it is just a default sprite group. But we want to create our custom drawing mechanic. So we are basically going to overwrite a few things inside of this class. And that basically means we have to create a class, and let's call it camera group. And in here, we have to inherit from pygame.sprite.group. And now this visible sprites is going to be a camera group. We have to get a couple of things in order before anything is going to work. First of all, we need an init method with self and nothing else. And just like we are doing for the tile and for the player, we have to initiate the actual sprite group. And this happens with super_init. So this is what we need in here as well. And now this camera group has the same functionality as a regular sprite group. So we could run our game and nothing would change, because we basically just put the sprite group inside of another class. So no change yet. But with this setup, we can make a couple of changes that are quite useful. And let me do one example. Let's say in my case, I want to create a custom draw. And this one needs self and nothing else. And for now, we are just going to replicate the usual, where do I have it? I want to replicate visible_sprites.draw so that this group is drawing all of our elements on the screen. And all that draw really does is this. We are going through for sprite in self.sprites, and then we call the display surface, so this one here, that we are getting via an argument. In our class, we don't have that yet, and you're going to see in a second why we don't have it. But for now, let's just assume we have it. So self.displaySurface.blit and sprite.image and sprite.rect. Essentially, the draw method really just calls blit with the image and the rectangle of any kind of sprite. And for that reason, when you create a sprite, you always have to set an image and a rectangle. Otherwise, you get an error. Now, I want to draw all of my elements with my custom draw method. And I don't want to use an argument to get the display surface. Instead, I want to get the display surface when I initiate this camera group. And this could be a good exercise for you. So when you initiate the class, try to get the display surface and store it in the attribute self.displaySurface and see how far you get. Essentially all we have to do. We actually have it right up here. So you can get the display surface with pygame.display.getSurface. And that's the same line we want to get in here. So now when we create the camera group, we are giving it the surface we want to draw on. So when we then call the custom draw method, we don't have to pass in an argument. Theoretically, when we are calling this class, nothing should change. And that still looks pretty good. Cool. No change there. And I'm quite happy with this. And I'm really bad at my own game, but never mind. All right, now we have our own custom draw method. What we are now able to do is to update this to include a camera. And for that camera, we need self.offset. And this is going to be pygame.math.vector2. And let's give this one a couple of default arguments. Let's say I want the x to be 100 and the y to be, let's go with a larger number, let's say 300. So hypothetically, I want to offset all of my images by this amount, 100 pixels to the right and 300 pixels down. All we essentially have to do is, before we are drawing all of the sprites, I want to get a new offset position. And then this offset position is where we actually draw the sprite. All that this offset position is sprite.rect.top left. So the information we already have. And then towards that, we are going to add our self.offset. And that's basically it. If I now run the code, you can see that the entire game is massively down and a bit further to the right. But all the elements are still there, except I think I just fell down the entire game. So in here, you can see that we can still jump on stuff, you just can't see it. So the actual rectangles are still in the game and the player knows where they are. We just happen to draw them in a different position. So that is working quite nicely. And all that we have to do now is to figure out how to connect this offset to the player. And you can do that in two different ways. Let me actually draw this on the window. So we can have two different cameras in here. One could be that we have our player in the center, let's say here, and the player is always going to be in the center of whatever we are drawing. So you always have the same distance to the right, to the left, up, and down. This is, for example, how Pokemon works, where the player is literally always in the center and you can never not be in the center. And this is the easier one, that's the one we are going to start with. Besides that, we could also approach this in such a way that we are drawing a square around the game that might look something like this. And if the player moves, let's say, to the left, then we are moving this entire rectangle, so our entire window, a bit further to the left. So the player has some freedom to move inside of the game, but once we get to the edges, then we are moving the window. And, well, let's implement both of those. And let me add a section. Let's start the first one with, let's call it center camera setup. And let me explain how this one is going to work. Imagine that this is going to be our entire window. And by default, this top left position here is 0 for X and 0 for Y. And in the example we just had, this top left position was 100 and 300. Effectively, this is our origin. And if we add anything in the vector, we are moving this origin, and then also this origin determines where stuff is being drawn. And what I want to do to always have the player in the center of the window would be that I have to find this distance here. And to figure that out, we need a few bits of information. And let me go through them. First of all, since our player is always in the center, we basically have to get half of the width and half of the height of our display surface. So let's call it self.half_width. And this we get with self.displaySurface and get_size. And this is going to return a tuple with the width and the height. And for the width, I want to get the first element and divide it by 2. Then I can copy all of this and get the height, and I need to get the height and still divide it by 2. And now I can use that information to draw on the window. And the first thing I have to do is to get the player offset. And essentially, I want to get a self.offset.x and a self.offset.y. And let me spell it correctly. And now let's figure out the offset for x first. And let's actually use real numbers. So I know when I initiate the player first, the x position is going to be 192. And this 192, I want to be exactly halfway from the left side of our window. So this is the distance I essentially have to get. And this number we can get with player.rect.centerx. Now, right now, we don't have the player just yet. We're going to work on that in a second. For now, just assume we can access the position of the player. Now, from the position, I want to subtract the half width. And right now, our half width is 640 pixels. So this number here essentially gives us 192 minus 640, which means that the distance we have from the left of the window is negative 448. So when we are starting the game, the x position is not 0, it is negative 448. And now we can just do the same thing for the y position. So we just want to get player.rect.centerY, and from that I want to subtract self.halfHeight. And now, let me get rid of all of this. We have to figure out one more thing. We need to get the player inside of this custom draw. So let me add a parameter in here. And now, when I call this custom draw, I want to pass in self.player. Although this one we also don't have right now, but we can get it because this player here right now is returning the sprite of the player. So we can just capture it in self.player and be done with it. So now this should be working. And it is not. But now if I move stuff, you can kind of see we have the player. Okay, this is kind of difficult to watch, but the problem here is, let me actually draw it. So if this is our window, and if the player is moving to the right, the camera should move in the opposite direction. So this way here. And all that means in practice is that this shouldn't be positive, it should be minus. And now let's try this again, and there we go. Now we have a working camera. And this one is working really, really well. And well, it's going quite okay. And there is no bug or anything. I am quite happy with this. Now that would then be the first kind of camera system. But I don't really like that one for this kind of side scroller because it feels like stuff is moving too fast. So I'm going to comment out all of this, and instead we are going to create let's call it a camera box. And now let me explain what I actually want to do, and let me uncomment those two attributes and open the game again. So right now, whenever our player moves, the entire game moves along with it, which doesn't feel great. I think especially for a platformer, it's a bit weird. So instead, I only want to move the camera left if my player, let's say, crosses this boundary. If that is the case, then the camera should move to the left along with the player. And then the same for all the other direction. So if the player crosses this line, then we're moving the camera to the right. And in practice, what that means is we are going to draw a rectangle on top of the window. And this rectangle is going to correspond with the display borders. So the right side of this rectangle is going to be the right side of our camera border. And then when our player goes to the right, we are going to move this rectangle. And then this rectangle is going to determine where stuff is being drawn. And as a matter of fact, when you look at settings, these are the camera borders that I want to define. So if my player is 100 pixels from the left, then I want to move my camera to the left. That's what this entire thing here is for. And well, let's implement this. And the first thing that we need is the position and the size of this rectangle. So we essentially need a camera left, we need a camera top, we need a camera width, and we need a camera height. And well, let's go for this one by one. Now, first of all, the camera left, and let me draw all of this. That should illustrate this quite a bit better. This here is our entire screen. And the left side should just be this distance here. So that's a really easy one. All we really need is from settings, I want to get my camera borders, and my camera borders, I want to get left. So essentially, all this really is 100 right now for us. And top works in kind of the same way. That we still need our camera borders, except now we want to look at the top. And this top is going to be this distance here. If you look at the settings, we have top. This is also going to be 100. So 100 as well. Width, unfortunately, is a tiny bit more difficult, but actually this could be an interesting exercise. Try to figure out the width and the height of this camera rectangle and see how far you get. Let me start with the width. That's the first one that comes to mind. And here's the approach I'm going to take. First of all, I'm going to take the entire width of our display surface. So right now, this would be 1280. And I know that my rectangle starts at position 100. That's the left side. And I also know the right side, that is position 200. So I also know that this size here, or this distance here, is 200. Which means that the actual distance I am interested in is this bit here. Which in practice means I need to get the entire width and then subtract 100 and subtract 200. So essentially I'm getting rid of this side and this side. Which means in terms of code, I want to get my self.displaySurface and I want to get underscore size and 0 for the width. And let me move this one a tiny bit further down to make it easier to read. And from that, I want to subtract we can actually get my cam left. And towards that, I want to add my camera borders and right. So this here is our camera left, and our camera right is this side. And that's basically all we needed. Now we have the width of this rectangle. And for the height, we basically have to approach this in the same way. We first have to get the entire height of the window, which we get with getSize as well. And from that, I want to subtract my camera top, and towards that add my camera borders, and now I want to get the bottom. And with that, we have a rectangle, which I have called the camera rect. And this is literally just going to be a Pygame.rect. We have cam left, cam top, cam width, and cam height. And now this camera is going to be moved by the player and also determine where the origin point of the window is. But first of all, let me comment out all the stuff from the center setup. So I don't want to get the player offset anymore. I want to get, let's call this camera offset. And in here, I still want to get my offset, because that is the same offset we need to offset the entire rest of the game. Except now, this offset will be determined by the camera rectangle. So this is basically how it's going to work. And the math we are going to need for this one, let me draw the entire window one more time, may actually be the last time. And in the last approach for this one here, we needed the distance from the center of the screen to the top left. And this way our player would always be in the center. Now for the rectangle, let's say this one here, we essentially want to draw a rectangle around the entire display surface, and now we need to find this distance here. So from the top left of our rectangle to the origin point of the window. So I want to create pygame.math.vector2 again, because we still need a vector. And in here, I want to get myself.camera_rect.left. And from that, subtract my camera borders and the left side. And then for the top, I want to get myself.camera_rect.top and subtract my camera borders and the top. And let me put this on multiple lines to make it a bit easier to read. And with that, we have a new offset point. Let's try to run the code and let's see what happens. And now, well, nothing is happening because we are not updating the rectangle. So now we have to figure out how to actually move this camera rectangle. And this is, let's add another section, getting the camera position. And this is essentially going to be a couple of if statements. For example, that if my player rect.left is smaller than myself.camera rect.left, so my player is further to the left than the camera, then self.camera rect.left is going to be player.rect.left. Essentially, all this means is if the player moves further to the left than the left of the camera, we are moving the camera to the left. And this should already be working. Let's try this now. And if I now move to the left, we can see that it only updates if we are moving to the left. However, if we're moving to the right, nothing's happening yet because we don't have code for that. But that we can add fairly easily. Let me actually copy this if statement. So if my player rect.right, that was horrible spelling, .right is greater than myself.cameraRect.right, then those two should also be right. And now we have left and right movement. Let's try it. So left is still working. And if I move to the right, we also get a smooth movement. So this seems to be working quite well. And all we have to do now is do the same thing for the top and the bottom. So in here, if player rect, let's say top, is smaller than the camera rect.top, then all of the tops should be updated. So now, there we go. This is still working just fine. And for the final one, we have to copy this one more time. And let me just change all of the tops to bottoms. This proper spelling, there we go. And now this needs to be greater than. And now we are done. So this is working really well. And this is a more common camera for this kind of game, which I think feels significantly better. And well, that is the entire tutorial. I hope you enjoyed it and got something out of it.